Hello, dear viewers. I hope you are doing great and having good health. From the title, you know that this video or the tutorials is about homologous series, and this is the fourth tutorial on organic chemistry series. Previously, I have uploaded the vital force theory and then hydrocarbons and the differences between organic and inorganic chemistry. In this video, we're going to learn about homologous series, and in the fifth tutorial, we're going to learn about what is functional group, and then after we will start the nomenclature system of UBEC organic compounds, and then after the alkane, alkene, alkynes will come successively. So in this video we're going to learn what? Homologous series. So simply the name tells everything, that homo word, it means same. Homo, it means same. So from the name itself we know that there is a series of compounds. The series of compounds where there will be a general formula but not the same molecular formula. So there will be different changes happening in a successive manner. So there are some characteristics of homologous series, and each member of these series is called homolog. So we say that each member of the series is called homolog. Okay, so what are the characteristics of homologous series? So previously what is said that homologous series is a series of compounds with same general formula but different molecular formula happening in just immediate succession. That is called homologous series. Now you see closely the characteristics of homologous series. Number one, very simple, that all homologous series will have a general formula. What is the formula? We know that carbon is the main or the core element of organic compounds. So with it, it might have hydrogen, oxygen, sulfur, phosphorus, nitrogen and halogens. So there will be a summations of elements in the organic compounds. Usually all the general formula, there is a specific general formula based on each and every single homologous series. I'll just write it up next, but try to remember one thing, that they will have a general formula. Second, successive members differ by a simple group, that is CH2 group or 14 mass unit, because you know that CH2, the atomic mass, relative atomic mass of carbon is 12, hydrogen 1 into 2, so together it's 14. So they will differ from their immediate successions as 14 mass unit. Third, they will have a same functional group. What is functional group and what is about? I'm coming at the next video. Number 4, they will have a common methods of preparation. And lastly, they will have a similar chemical properties or even physical properties. Okay, so before going to explain what are the characteristics, you must remember these things, which is very simple. Now you see that homologous series, number 1, if I say this is alkane. Alkane. So this is one of the homologous series. Alkanes, their general formula is Cn, the number of carbon, and hydrogen would be 2n plus 2. 2n plus 2. What is this? Suppose the number 1, if the number 1 carbon is 1, so we say that C, so hydrogen would be 2 times 1 is 2 plus 2 is 4, so that is CH4, and this is methane. If the number of carbon is 2, then it would be 2 times 2 plus 2, so it should be 2 times 2 plus 2, and that is C2H6, and this is ethane. What about propane? If there is number of carbon is 3, then hydrogen should be 2 times 3 plus 2, because the general formula of alkane is always CnH2n plus 2. So the number of hydrogen is always twice plus 2 than carbon. That should be always remembered. So in case of propane, if there is number of carbon is 3, there should be C3H8. So now you see closely, every time CH4, C2H6, C3H8. If I just tell you the formula is like this, CH4, like this. And then this carbon and carbon are joining together with a covalent bond, and this type of bond is called sigma bond. And in case of propane, it should be like this. So now you see that every time, what is happening? What is happening? Each time they are differed by CH2. Again you see, this is CH3, this is CH3, and in between them there is CH2. So every time they will differ from their immediate successive members by this CH2. So if you say that pentane, hexane, heptane, octane, nonane and decane, immediate successive number will differ by CH2 group or 14 mass unit. So very simple. So in case of alkane, the general formula is CnH2n plus 2. CnH2n plus 2. So when we say that the successive numbers like methane, ethane, propane, butane, they will differ by this. And all these alkanes, they're having a general formula. Good. They have this successive group difference. They have same functional group, CnH2n plus 2, common method of preparations, and of course similar chemical properties. Okay. In case of alkene, the general formula is CnH2n. So the number of carbon and the number of hydrogen is just twice of number of carbon. What? C2H4 is ethane. So some of you may ask why methane is not there, because alkene, it means that carbon and carbon will have at least a single double bond in between them. So to make this double bond, there must be 2 carbon each other. So other this carbon valences will be occupied by hydrogen. And that is why the first member of alkene group or alkene homologous series is C2H4, that is ethane. So why we say this is ethane? Because the carbon numbers is 2. We know that according to the Greek numbers, meth, it means carbon 1, carbon 2 is eth, carbon 3 is prop, carbon 4 is but, carbon 5 is pent. So after that, will we use N or in or ein? It depends on the functional group. Here we see that carbon and carbon are binding together with a double bond, and this is the functional group. So when we see the functional group is carbon double bond to carbon, that is alkene. And then we can find the name of the compounds according to the UPEC system. So what is UPEC system? Simply we can memorize one thing, that the number of carbon determines first the name of the compounds. So now you see we have 2 carbons and 1 double bond. So this double bond is the functional group of alkene. So this is alkene, but it has 2 carbon. It's called ethane. If there is 3 carbon, like this, at least they will have 1 double bond, that is propene. Now you see that carbon valences is 4, so they will have 2 carbon, 2 hydrogen, 1 hydrogen and 3 hydrogen. So simply we can write this So what is the formula of propene? 3 carbon, so it has 3 carbon, so hydrogen should be 3 times 2 is 6, so hydrogen would be 6. Now you count 1, 2, 3, 4, 5, 6. So what is the differences between ethene and propene? If you just subtract ethene C2H4, then you will find CH2 group. So the successive numbers. Successive number means immediate next member. So propene is CH2 group higher than ethene, and similarly butene would be CH2 group higher than propene. So what is the formula of butene? That should be C4H8, as because twice. So this general formula is very important, and it's called butene because we see that the number of hydrogen is twice the number of carbon, and the number of carbon is 4. So we know this is butene. In case of pentene or hexene or decene, number of carbon is 10 and number of hydrogen is 20. So it tells us the formula is C10H20, means there are 10 carbons and 20 hydrogen. So the 20 hydrogen is twice the number of carbon, that is CnH2n formula analysis, alkene. And all the members like ethene, propene, butene, they are the homolog. As we know, the members of homologous series are called homolog. Okay? Now you think that alkene is C2H4, that means CnH2n. So ethene is the first member of alkene group. And number 3, if we say for alkyne, then what is this? Alkyne is CnH2n minus 2. Simple. If there is 4 carbon, then hydrogen would be 4 into 2 minus 2. So 4 times 2 is 8 minus 2 is 6. So it should be C4H6. So it tells us the formula is, the name of this compound is butane. As because this is alkyne, we know the functional group of alkyne is carbon-carbon triple bond. If there is a single triple bond in the compounds, then it's alkyne. N, Y-N-E, Y-N-E. Before E-N-E, in. And then before A-N-E, N. In case of N, it should be single bond. It should be double bond. It should be triple bond. So alkene, alkane and alkyne depends on the functional group. So whenever we see there is a carbon-carbon triple bond, it means this is alkyne, and the name of that group depends the number of carbon. Meth, eth, prop, but, pent, hex, hept, oct, non, dec, and then after undec and dodec, and then you can continue. The number of carbon varies. Okay, so I hope this is okay. In case of alkyne, it will have what? It will have carbon-carbon single bond. In this case, carbon-carbon single bond. In this case, carbon-carbon double bond. In this case, carbon-carbon triple bond. But as we know that valence of carbon is 4, so we must occupy the other part. So it should be 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 1, 2. See, if you go a little bit further about aldehyde, then this is CnH2n plus 1 CHO. So CHO is the functional group of aldehyde. So whenever we write something like, suppose C3, carbon number is 3. So hydrogen should be 3 times 2 is 6 plus 1 7. So C3H7CHO, that is actually butyl. Butyl, because the number of carbon is actually 4. Because there is another CHO, so simply we can write it C4H8O, that is aldehyde. So we can say this is butanol or butyl aldehyde because the number of carbon is 4. And simply we can say that C6H, 6 times 2 is 12 plus 1 is 13 CHO. So altogether there is 7 carbon, so that should be heptyl aldehyde or heptanol. I'll come up with the functional group names, but before going to digging up that, I'm just giving you a simple idea. So the aldehyde is CHO. In case of alcohol, you see that CnH2n plus 1 OH. So OH is the functional group for alcohol. So whenever we see that number of carbon is 1, so it should be 2 times 1 is 2 and then 1. So the first member of alcohol group is CH3OH, and this is called methanol. Now you see the second members, the successive immediate members is CH3, CH2OH. This is ethanol. And one more thing that we mentioned, that the physical properties and some other properties also closely varies based on the numbers. Like here, the methanol, the boiling point of methanol is nearly 65 degrees Celsius. 65 degrees Celsius. But you see the boiling point of ethanol is 78.3 degrees Celsius. If you go for propanol, the boiling point would be much more higher. Gradually it increases when the number of carbon increase in each homologous series. Because when carbon numbers is increasing, the sigma bond is also increasing. So there will be more requirements of heat if we need to break down the bond. So when the number of carbon increase, the boiling point, the melting point, density and some other properties gradually increase. So alcohol is CnH2n plus 1 OH. Now if you see simply that alcohol, aldehyde, carboxylic acid, then this is CnH2n plus 1 COOH. So again COOH is the functional group of carboxylic acid. So this is another general formula of carboxylic acid. So if you go for HCHO, that is methanoic acid. If you go for CH3COOH, then it's actually ethanoic acid. So successive members are differs by CH2 group. Okay, so there are other things that should be mentioned here, but I'm just giving you a simple idea that alkane is a homologous series. Alkene another homologous series. If you go for number of carbons, you can go till along methane, ethane, propane, butane, pentane, hexadecane, octane, nonane, decane, undecane, dodecane, tridecane, tetradecane, a lot. So each numbers differs. So the main purpose of this tutorial is to remind you what is homologous series. So simply we know that, you see, the homologous series CH4 methane, C2H6 ethane, C3H8 propane, C4H10 butane, C5H12 pentane. So each members are called homolog. They differ by CH2. They will have general formula. They will have similar chemical and physical properties. And some changes happens gradually if there is increasing of the number of carbon. So please remember these characteristics of the homologous series, and of course I'm coming up next with the functional group tutorials. I hope you understand this one. If you have any questions or any feeling or any other thing to let me know, please do not hesitate to write in the comment sections of YouTube, or even you can communicate with me and through Facebook. So take care, stay well, see you on the next video with functional group.